Let us solve the continuation of the experiment, node voltage analysis. We have two problems under this with respect to dependent source and only independent source. So earlier we have solved 5.1 with both independent and dependent. 5.2 only independent source. So the aim and application of the problem. So for node voltage analysis, one is Ix, Iy, Iz, and the voltage Vx and Vy. So this is your voltage Vx, Vy, and these are the currents Ix, Iy, and Iz. So let's see how do we solve them. Let's move on to theoretical calculation. Now, is this a normal node or super node? So I want you to analyze. Pause the video, analyze, and then you can resume once you have your answer. This is a normal node. So we have three junctions. Let us name them as V1, V2, V3, and bottom is grounded. So let us apply node voltage analysis at V1. At V1 we can see we have two currents, 4 and 2. So it's very easier, and you have to only write for the current which is going towards V2. So we write the equation is plus 4 plus 2 plus V1 plus 1 minus V2 whole by 10 is equal to 0. And when we simplify, this is your equation 1. Similarly, for equation 2, at V2 when we apply, we get V2 minus V1 minus V1, V2 minus 1 minus V1 whole by 10, and V2 minus 4, this current, that is V2 minus 4 by 7, and V2, this current going towards right, V2 minus 3 minus V3 whole divided by 2. So when you simplify, we get second equation. Similarly, when we apply at 3, the equation is minus 2. As you can see, 2 amperes entering, we write that as minus 2, and the current going left is V3 plus 3 minus V2 whole divided by 2. The current going down as V3 by 1. So when you simplify, you have equation 3. So when you substitute all the three equations in your simultaneous equation and you solve, you get the answers for V1, V2 and V3. So I want you to substitute, write down your answers, and then you can resume and then check your answers whether they are right or wrong. So the answers for V1, V2, V3 are minus 68.9, minus 7.9 and minus 2.3 volts. So first what we'll do is we'll try to find out the answers for the aim, that is find out Ix, Iy, Iz, and then Vx and Vy. So in this I'll not be showing you the answers for V1, V2, V3. I'll leave it to the user, the students, to find out the answer for V1, V2, V3, because that is not the aim of the experiment. The aim of the experiment is with respect to the current and voltage Vx and Vy. So let's move on to find Ix, Iy and Iz. So Ix, as we know, the formula is V1 plus 1 minus V2 whole divided by 10. You get the answer as minus 6 amperes. Similarly, Iy is V2 going down by V2 minus 4 divided by 7. You get the answer as minus 1.7. Iz is current going right from V2. So V2 minus 3 minus V3 whole by 2. You get the answer as minus 4.3. So earlier we have already solved for V1, V2, V3. So once you substitute, these are the answers that one should get. Similarly, these are the answers. You can substitute and you can verify your answers. Similarly, we have to solve for Vx and Vy. So Vx is equal to 10, and the current Ix, it is hitting positive of Vx, thus the symbol is positive. So it is minus 6, positive of 10, you get minus 60 volt. Vy, the current Iz, it is hitting negative of Vy, thus it is minus Iz into 2, you get the answer as 8.6 volts. Now let's check how do we connect the circuit in PSpice. But before we go to the connection, one should know what all are the parts required. So you can see we have 1, 2, 3. We have 3 VDCs and we have 1, 2 IDCs. How many resistors we have? 1, 2, 3, 4, 5. We have 5 resistances and we have 1 common ground. So these are the parts required for simulation. Now let us build the circuit in PSpice. As a simple problem, I have already built the circuit. However, you can verify your answers after building the circuit connection. Now one should note that the voltage polarities should be connected as per the diagram. So in the diagram they say that positive is towards right for one node, and a positive is towards left for one node, and positive is stopped for 4 volt, and the 2 ampere is going right and 4 ampere is going down. So these things is what you must take care. Now as told earlier, I will not be showing for V1, V2, V3. Let us try to find out the answers for the aim of the experiment, that is I1, Ix, Iy, Iz, Vx and Vy. How do we build we have already seen how do we build the circuit. Let's check for the results, right? So the results, let us see for Ix, Iy, Iz, Vx and Vy all together. So let me arrange the circuit. Now, if you remember the currents, Ix was going towards right, so place it towards left. Iy current was going down, so place it at the top. Iz is going right, so place it at left. Okay, so I think I have placed this twice. Let me check. No, I have placed it once. Let me place the current. Okay, so I'll shift the current marker to Vy here. I have a different agenda. I'll explain why I did so. Next, so this I'll rename this V2 as Ix, and I'll rename this R4 as Iy, and I'll rename V1 as Iz. Next, we need Vx and Vy. So if you remember the polarity for Vx, let's go to marker, take positive. So positive was at the left and negative was at the right. Similarly, for voltage across 2 ohm, positive was at the right and negative was at the left. Okay, let us rename this R1 as Vx and R2 as Vy. Now we have renamed as per our problem. I have already enabled transients, and when we simulate, let's check our results for all the unknowns. Toggle cursor. Let's check with Vx first. So this is your Vx. So yes, we are getting. I am using only A1 cursor. So kindly do not observe for A2 cursor. So as I use my left click, you can see the answer is matching with the theoretical calculations. Next, Vy. Click on left using your left mouse button. 8.6. Yes, 8.6 is matching. Ix. What should we get? We should get -6. Yes, we are getting -6. Iy. So click on Iy, -1.7, -1.7. Iz, -4.3, -4.3. Thus, theoretical calculations and simulation, both the results are matching. Thank you.